Hey, Algebra, it's Mr. Florio. I'm not going to be here today, so you're going to just be taking notes on this lesson. You guys can try these questions on your own and then come back and watch the video. And you can see kind of either how I did it or if you got stuck, you can just write what I have down. But just make sure you have this down in your OneNote page. So this is lesson 22.22 from the class notes. So here we go. The landscaping options. A homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in other parts. Grass sod is installed at a cost of $2 per square foot, and the flower beds installation costs $12 per square foot. Her budget for the project is $3,000. So we have $2 per square foot of sod. The flower beds are $12 per square foot, and she has three grand to spend. Write an equation that represents the square feet of sod X and the square feet of flower beds Y that she could afford if she used the entire budget. So X, they just told us here, is the square feet of sod. So X equals the sod, grass sod, in square feet. And Y is going to represent the flower beds. In square feet. Okay. So sod's kind of like that grass that you kind of like roll out and it kind of like just works its way into the soil. But you can kind of like pick it up and roll it out. You don't have to like grow it. Anyways, so the grass sod costs $2 per square foot. So $2 for every square foot of grass sod. And it's $12 for every square foot of the flower bed. And if she wants to use the entire budget, her cost has to equal $3,000. So on this coordinate plane, we're going to graph it. So simple enough. You guys can try graphing it on your own. You could type it and graph it with the graphing calculator, but I'm going to do this by hand. The easiest way that I see to graph this one is let's look at what happens if I use if x is 0, meaning there's 0 square feet of grass sod. How much flower beds can I pay for? So it's $12 for each foot of flower bed, and I have $3,000 to spend. So 3,000 divided by 12. If by 0 square feet of grass sod, I could have 250 square feet of flower bed. How does that help me graph? Because if I buy 0 sod, that means I could buy 250 square feet of flower beds. So that gives me 1 point, and I can just do the same thing if I buy 0 flower beds, 0 square feet of flower beds. Then I can spend all of my money on the sod. It's $2 for each square foot of sod, and I have $3,000 to spend. So I can divide both sides by 2. That means I can buy 1,500 square feet of grass sod. So when Y is 0, when I have 0 flower beds, I can buy 1,500 grass sod. So now that I have those 2 points and I want to graph the line, all I have to do is connect them. So that's why I did that whole process. So that looks good enough. Okay. So I just use my ruler to make it look nice. Okay. Simple enough. So that's if I want to spend exactly $3,000. Now let's look at 22.2. Rethinking landscaping. The homeowner is worried about the work needed to maintain a grass lawn and flower beds. So she's now looking at some low maintenance materials. So instead of these high maintenance stuff, let's look at some cheaper materials. She's considering artificial turf, which is $15 per square foot to install, and gravel, which costs $3 per square foot. So this stuff might be easy, less maintenance involved. It might not be cheaper, but less maintenance. You don't have to mow the lawn as much. She used a combination of these materials, and her budget is $3,000. Here's a graph of some of the constraints of the situation. So This line represents the amount of money she can spend if she want, the amount of gravel and artificial turf she can have for $3,000. So here we see that the graph shows a line going through 5, comma 100. In this situation, what does it mean? Well, X is 500. That's the amount of gravel in square feet. So she can have 500 square feet of gravel. The Y is 100. That's the artificial turf. So 500, comma 100 means 500 square feet of gravel and 100 square feet of turf. Since that point is on the line, it would spend. That means it'll cost exactly $3,000, which is her budget. Write an equation that the line represents. All right, certainly. So x, I'll let x be gravel in square feet, and we'll have y be artificial turf. So we know the gravel costs $3 per square foot. So $3 for each square foot of gravel, plus $15 for each square foot of $15 for each square foot of turf. So the turf is $15 and the gravel is $3. And we have a budget of $3,000. So what we spend has to equal $3,000, so it hits our budget. So that's part B, actually. Part C, what do the solutions mean? So any solution to this equation is going to be the amount of gravel and turf that this person can purchase, and have it last. And have it cost $3,000. So the solutions are the combinations of gravel and turf she can buy for $3,000. Okay. So the point 600, 200 is located right above the line. So that point is right here. Does that combination of turf and gravel meet the homeowner's constraints? Explain your reasoning. So if I buy 600 square feet of gravel and 200 square feet of turf, will I be within budget? Well, I'm going to use my calculator to do this. Let's see here. It's $3 for each square foot of gravel times 600 feet. Plus, we have $15 for each square foot of turf times 200 feet of turf. That's going to be $4,800. That's above budget. No, 4,800 is greater than 3,000. It's above our budget. It's over budget. Okay. So what I just did is I used the equation that we have up here, 3x plus 15y equals 3,000. I plugged in 600 and 200 and saw that it came out to 4,800, which is more than the 3,000 that we have. So right, I have 3x plus 15y equals 3,000. When I plugged in 600 for x and 200 for y, I got 4,800, which is way bigger. So it's out of budget. Choose another point in the same region. So let's look at another point above the line and check if that combination meets the constraints. So this one did not meet the constraints. That did not put us under budget. But what if I look at another point? Let's look at, I don't know, so some point up here in the top right. It doesn't matter. Let's use this point right here. So this point is 400 and 150. So let's use 400, 150. Any point up there will work for this problem. So I'm going to plug in 400 for x and 150 for y. So I'm just going to copy this so I don't have to type it again. And so instead of 600, it's going to be 400 square feet of gravel and 150 square feet of turf. So multiply that by the $15 for each square foot of turf, multiply that by the $3 for each square foot of gravel. And that's going to come out to $3,450. That's still over budget. That's still over budget. That's still over $3,000. So both of these points were over budget. And the point on the line hit our budget exactly. Well, what about the point 200, 100? So this point down here, under the line, does that meet our constraints? Does that keep us under in our budget? So our equation is still $3 for each square feet of gravel plus $15 for each square feet of turf, and our budget is $3,000. So let's try this. I'm going to just use that same thing, but this time I'm only going to buy 200 square feet of gravel and 100 square feet of turf. And that comes out to be 2,110. Yes, that is in our budget. That's less than the $3,000. It is within our budget. Choose another point in that region and see if that combination meets the constraints. So if I want to pick another point in this region, and I don't know, let's use this point right here. This is 150. 100 square feet of gravel and 50 square feet of turf. So let's use that equation again. And I'm just going to use the last one and just make sure I'm using 100 for x and 50 for y. 1,050, yeah, that's under budget. 1,050 is within our budget. Or within their budget. Write an inequality that represents the constraints of the situation. Explain our answer, and we'll shade and show the solution on the graph. So the 3x is how much it costs for gravel. The 15y, if I add that's the cost of turf. That needs to be under $3,000 because that's our budget. It could be $3,000 or less. So that is our inequality, and it looks like all of the solutions were the ones under the line. So remember, we highlight the region. All solutions to that inequality are right here. What that means is if this person wants to spend under $3,000, any point in this green region, any point on the line or under the line, will be within our budget. So any point here, it doesn't matter which one you pick, any point will be within budget. Any point outside of that line is out of budget. So you don't need to really do computations to say yes or no. You can just look at the graph, and anything that's shaded region is a solution. So 22.3, the Saturday market. A vendor at the market makes $9 for each necklace and $5 of profit for each bracelet. Find the combinations of necklaces and bracelets that she could sell to make exactly 100 or more than 100. Okay, so if I want to make exactly 100, let's see. If I make 10 necklaces, that would be at $9. That'd make me $90. So then I'd have $10 left to make. So I can make let's say 2 then, right? 2 bracelets. That would be at $5 a piece. Would be $10, and that would give me the $100. So if let's let n be the number of necklaces sold and b equal bracelets sold. So if n equals 10 and b equals 2, that'll get us $100 of profit. Not bad. If I want it to be more than $100, I just need to sell more than 10 and 2. So I could send maybe 11 necklaces and 2 bracelets will be fine. Let me just sell one more for the fun of it. Because that would be $99, $9 each. This is $5 each, so that'd be $15. That would be $114. Again, over $100. Okay. So write in an equation that whose solutions is a combination of necklaces and bracelets you could sell to make exactly 100. Simple. So it's $9 per necklace plus $5 per bracelet. That's how much she makes. And if she wants it to be equal to 100, right, equals 100. Write an equality for solutions of the combinations of necklaces and bracelets she could sell to make more than 100. So if it's $9 for each necklace and $5 for each bracelet, I want that to be more than 100. That's going to be greater than 100. Simple enough. So it looks like the x-axis is the number of bracelets and the y-axis is the number of, the x-axis is the number of necklaces and the y-axis is the number of bracelets, and it wants us to graph the solution. I'm going to do what I did before. If I sell 0 necklaces, then I could only sell bracelets, and if I wanted to make $100, then I need to sell 20 of them. Just divide by 5. So if I buy 0 necklaces, I can afford, as long as I sell 20 bracelets, I'll make $100. And if I sell 0 bracelets, then how many necklaces would I need to sell? Do 100 divided by 9, so $100 divided by $9 each. Necklace, I'd have to sell 11 or 12. Let's say 11.1 is just over 12. 8, 10, so it's going to be right around here. So these 2 points are on my graph. Let's get the ruler out. I could just connect these 2 points to make the line, and there's my graph. Oh, I'm gonna make these dashed lines. Does anyone remember why I'm making these a dashed line from last class? And the reason is because of the inequality here. It's not, I want to make $100 or more. I want to make strictly over $100. So anything on the line would be exactly $100. So I don't want to be on the line. I want to be off the line. I need to either be above or below the line if I want to make over $100. So if I want to make over $100, I think I'm going to need to be over this line. Right, and if we look, remember 11.3, if we look at that point right here, 11.3 is right about here. That is over the line. So that is a solution. So all my solutions are going to be on this side of the line. So anything on or below the line is not going to be a solution, but anything above the line is going to be a solution. Okay, so that would be my solution set. And now that I have that, this question is going to be easy. Is 3, 18.6 a solution? Well, let's see what region 3, 18.6 lies in. So that's 2. So 3 is right here. And 18.6, let's see. 16 is right here. So 18 is here. So that's right around here. That's in our solution set. So it is a solution. Yes, it is in the solution region we shaded. So anything in that green area is going to be a solution, and the 0.3, 18.6 happens to be here, which is in our green region, so that would certainly be over $100. And you could even check if I did the 9 times $9 for all three of these, and $5 for all 18.6 of the bracelets. That would be more than $100. All right, last question. Charity concerts. A popular band is trying to sell at least 20, trying to raise at least 20 grand for charity by holding multiple concerts at a park. It plans to sell tickets at $25 each for 2-hour concerts. The band would need to pay the park $1,250 in fees for like security, cleaning, and traffic. So the band needs to find a combination of numbers and of tickets sold T and concerts held C that would allow them to reach their goal. So T is our tickets, and C is our concerts. Write an inequality that represents the constraints of the situation. So we want to make $20,000 at least, so that means $20,000 or more. We're making $25 for each ticket we sell, but we have to spend $1,250 for each concert. Whatever we make, we want it to be at least $20,000 or more. So it's going to be equal to $20,000 or greater than $20,000. So there's our inequality. Now graph the solutions to the inequality on the coordinate plane. So instead of us graphing it, tickets is X. It looks like concerts is Y. So I'm going to rewrite this with X's and Y's. Oops. And I'm just going to have the computer graph it for us. So watch this. 25x minus 1,250y. The greater than symbol on your keyboard is right near the M. Just go to the right of the M twice. We want it to be greater than or equal to, so put the greater than and then an equal to sign. 20,000. I'm going to highlight that. I'm already in draw, so just go to math. So draw, math. There it is. They changed the symbol for us. Select action. We're going to graph that inequality. I need to move this a little bit because I'm not seeing what I want to see here. So I'm going to click and drag a little bit. We'll zoom out as well. Well, there's 0, so we're almost there. Let's do a little bit more. And let's see if I can move this over. Touch. We're only interested where the numbers are positive, right? If we're selling tickets, we want a positive number of tickets and a positive number of concerts. Does that look good? Looks good to me. Yeah. So right here, if we have our x-intercept, it looks like it's going to be 800. So right here is where 5, 6, 7, 8, 9. Yeah, 5, 6, 7. So this is where the graph starts, and then it's going to kind of go in that direction. I'm just going to insert this to page. So that's our solution. Name 2 possible combinations of tickets sold that would allow them to meet their goal. To meet their goal, you just have to be in this region. So you have to be in the positive end of the region. So anywhere in here will work. So let's look at, I don't know, what are these going up by? 1, 2, 3, 4. So this is like 10, 20, 30, 40. So what is this? 10, 2,000. That would work. So if I had 2,000 tickets for 10 concerts, that's in our region, so that will make us at least $20,000. If I did 5 concerts, and still sold 2,000 tickets. So less concerts, same amount of tickets. I'm going to make the same amount of money, but spend less on concerts. So either one of those numbers would, either one of those points would be a solution to the situation. Number 4, last question. Which combination of tickets and concerts would mean more money for charity? 13,000 tickets and 10 concerts, or 13,000 tickets and 5 concerts? 13,000 tickets and 10 concerts. So the same amount of tickets, the more concerts, the more money I'm going to spend. And I want to make money, not spend money. So this one's going to be the cheaper one. Which one would I make more money? 16,000 tickets and 16 concerts, or 12,000 tickets and 9 concerts? Well, I'm not sure. So I'm going to actually calculate this one. 16,000 or 1,600 tickets at $25 each. And I'd have to subtract the 16 concerts at $1,250 each. All right, so that option would make me exactly $20,000. Okay, but if I sold 12,000 tickets, or excuse me, 1,200 tickets at $25 each, subtracting out the cost of the 9 concerts at $1,250 each. That would be 18,750. So this one's going to make more money than that one. So it's going to be, although I'm spending more money on concerts, I'm selling a lot more tickets, and so I'm going to make enough money to make more money that way. Same thing on the bottom one. So if I have 2,000 tickets, it's $25 for a ticket times 2,000. And I have 4 concerts, so 4 concerts at 1,250. That's going to come out to be $45,000. That's going to be way over budget, or that's going to be way more than the 20,000 that we want. But is that going to be more than having 2,500 tickets at $25 each? And then we'll have to spend money on 10 concerts at $1,250 each. 50,000. So this one's going to be better. This one will make $50,000. That's more than 45,000. So that one's going to be better. Anyways, this last one we're going to skip. That's it for today. You guys' homework is posted and assigned in OneNote. And if you didn't get the quiz done, make sure you get that quiz done and then get that homework done. All right. Have a great day. See you guys on Wednesday. Bye.